So good morning, Hematology 2 students. So this is G once again. So welcome to the final term of Hematology 2. And for this morning, we are going to discuss our no, this is the third from the last topic. We have mixing studies. So I'll be handling your class this morning. I just buffed. Okay, so I hope you did well in your semi-final examination. So this lecture is very short. As long as you understood the mechanism and how the flow of the test is being done to identify which factor is deficient from your patient, then you can just what you call this, get the answer for the activity and as well as the next quiz. So, hello. And before we start our formal lecture, I have received special request for shout out once again. So I hope you don't mind because as I record this video, one of my students are celebrating her birthday today. So happy birthday to Marigold Tagarda. Hi. And also shout out to the rest of her Ardiente family friends. We have Katlea, the leader, and we have Ara, Francis, Hannah, Johanna. We also have Jason, Neil, and Sen. Hello. And also to the council president, John Daryl Nakwa, and also lastly to the lovebirds of Liceo before we have Laura Del Tubio and Lance Britannia. Okay, so we are gonna move to our lecture this morning. So mixing studies. So as a review, this came out in your exam. I hope you were able to answer the coagulation deficiencies. This was a review on our lecture that was mentioned in the semifinals. And we have the names of the different factor deficiencies, the inheritance, as well as how are you going to differentiate them here in the laboratory result for coagulation deficiencies. Now, there are some of these tests that are sharing same of the laboratory coagulation test results. So that is why it would be difficult to identify with just checking on the symptoms as well as checking on the laboratory results because, for example, factor 8 and factor 9 deficiency share a common symptom manifestation, genetic inheritance, as well as laboratory results. So that is why we need to do mixing studies. Now, your mixing studies or your substitution studies, since your screening test, we have APTT and prothrombin time, cannot readily identify what is the specific factor that is missing from your patient. So definitely it does not detect what is the missing patient factor. It just screens that there is a problem with a particular pathway. So a specific factor deficiency may be identified how? By mixing studies in which mixing reagents are being mixed with patient's plasma, then you do correction by repeating the prothrombin and APTT. Now, in this test, you're just gonna mix the patient's plasma, which is your citrated plasma. You're gonna mix it with mixing reagents that will substitute the missing factor of the patient, and then we will check if the APTT and prothrombin time has been normalized. So if that's the case, then we can identify what factor is missing from the patient. Now, what are the mixing or correction reagents that are added in your patient's plasma? We have what we call adsorbed plasma, that is reagent 1. So your adsorbed plasma is a plasma with the addition of aluminum hydroxide or barium sulfate. And the next one is your age serum, which is the preparation. This is going to be discussed on your laboratory classes. A detailed explanation for this one is written in your laboratory manual. And because I did recycle this phrase from my laboratory class discussion before. So I was handling hematology lab before, so I apologize if this was not updated. And we have the adsorbed plasma and the age serum. So what are their difference? So the adsorbed plasma contains the following factors. We have factor 1, factor 5, factor 8, factor 11, and factor 12. The factor 12, prekallikrein and kallikrein, as well as high molecular weight kininogen, is difficult to differentiate in your mixing studies because they just have the same. But of course, factor 12 deficiency, high molecular weight kininogen, and prekallikrein, they do not manifest that particular bleeding tendency. That's how you differentiate it with factor 11 deficiency. Now, your age serum contains these factors. You have factor 7, factor 9, factor 10, factor 11, and factor 12. Okay, these are the factors that are found in that particular specimen, which is your age serum. Okay, now how do you remember? Since it would be difficult for you to just memorize what is found in the adsorbed plasma and what is found in the age serum, because these factors would be the one that will substitute what is lacking from the patient and why it had an abnormal APTT and prothrombin time. So this is the rationalization on how it's being done like that, so that you as students will be able to comprehend and remember why the adsorbed plasma contains those particular factors and why the age serum contains these particular factors. So your adsorbed plasma contains a plasma that has been adsorbed with barium sulfate and aluminum hydroxide. Now, your vitamin K dependent, if you could remember in our lecture on the secondary hemostasis in the midterms, we have discussed that you need to remember the vitamin K dependent factors because they can be mentioned again and they are mentioned again in the mixing study. So your vitamin K dependent, which is 2, 7, 9, and 10, these are the adsorbed plasma, meaning once aluminum hydroxide or barium sulfate is added to your plasma, they would be adsorbed or attached to this adsorbable component, which leaves only factor 1, factor 5, factor 8, 11, and 12 on the adsorbed plasma. Okay, I repeat, vitamin K dependent are absent in the adsorbed plasma. While your age serum, factor 1, factor 2, factor 5, 8, and 13 are consumed during coagulation, thus are absent in the serum, particularly age serum. And of course, factor 13 is not detected with prothrombin time and APTT. So of course, since you're just going to repeat APTT and prothrombin time in the mixing studies, therefore it still cannot be detected. So thus, in the age serum, you are gonna leave only factor 7, factor 9, factor 10, factor 11, and factor 12 in the serum. So that's the reason behind. Okay, so again, what is the test specific for factor 13? Okay, you have your Dockert's test using your urea or monochloroacetic or acetic acid. Now, again, I repeat, all of the factors are present in the plasma, but once you put adsorbable component, the vitamin K dependent will be absent. So it's gonna disappear from the plasma. So that is why your adsorbed plasma does not have the vitamin K dependent. While your age serum contains all of the components except those that are consumed during coagulation, such as 1, 2, 5, 8, and 13. They are not found on your age serum. The principle of our mixing study, so in patient, so we know that there is a factor deficiency once the patient develops abnormality with a prothrombin time, APTT, or both. Now, if the problem is in the extrinsic pathway, the prothrombin time again would be prolonged. If intrinsic, APTT. If both, common pathway. So the patient, after testing, and you have seen that there is abnormality, the patient sample is mixed with adsorbable plasma and age serum, and PT and APTT is checked, and if it is tested and checked if it is already corrected or not. When you say corrected, the results became normal. So what does it mean when the results became normal? It means that the factor that is deficient in the patient, which made his APTT or PT abnormal, it was already substituted by the adsorbed plasma or the age serum. So that is why when you repeated prothrombin time and APTT, it became normal. Now, if the result is not corrected, if the results still remain abnormal, let's just say The patient initially had an abnormal APTT and prothrombin time. And then when you mix the patient's plasma with adsorbed plasma and H serum, the APTT and PT is still abnormal. Therefore, there is no correction. Is it significant, Sir Gio, if it is not corrected? Yes, because you know that H serum and adsorbed plasma has some factors that are lacking in your patient, lacking in that sample that could be the same that is lacking in the patient. Therefore, there is no substitution to be done. Like for example, factor 2. If factor 2 is deficient, then it is absent in both H serum and adsorbed plasma. Therefore, the patient's result will still be not corrected. Okay, you will understand that as we move forward. Okay, this is the first step that you're gonna identify. You need to identify what pathway is affected because that is very important so that you will be able to easily rule out what is the factor that is deficient in your patient. So your abnormal APTT and prothrombin time, common pathway deficiency. So when we say common pathway, what are the factors? It's either a deficiency in factor 5, factor 10, factor 2, and factor 1. Okay. If both APTT and PT of the patient is abnormal initially, this is prior to the mixing study. And then when the abnormal is in the prothrombin time, that is the extrinsic pathway, and that is only factor 7 deficiency. If abnormal APTT is detected in the patient, intrinsic pathway deficiency is being observed. So when you say intrinsic, that includes factor 12, 11, 9, and factor 8. Usually deficiency with factor 10, factor 12, as I have stated, prekallikrein and high molecular weight kininogen do not show bleeding tendency. So it's rarely for these patients to manifest hemorrhages. Okay.